And then you have some stuff to do today. 4.1, 4.2 is due today. Tuesday, I moved this to next Tuesday, and I moved that to next Thursday because our exam, there's no way we're going to get to our exam by a week from today. I'm going to move it back to the following Tuesday, so it'll be a week from Tuesday. That way Tuesday we finish up all the material for these chapters, and then Thursday we can kind of review everything, and then you have your exam on Tuesday, the following Tuesday. Project Part 2A in the back of the room is super easy. It literally should take you 5 minutes. It's not even any real hard work. All it is pick 4 questions, write down what those are, and commit to them. So we had 4 groups in our survey, right? Group A, Group B, Group C, Group D. Group A was questions 1 through 8. Group B was questions 9 through 15. You need to pick one, and it says what they are, right? It tells you what the groups are. You need to pick one from each group. Do not pick the same question for any of the groups as your neighbors, as people you work with in the class. If you are, I'm going to kick it back to you and make you pick again. All right, so don't pick any of the same questions as your friends are picking. And then write down what they are. And then down here, you need to have qualitative data for this part. Which ones are the qualitative data? Qualitative data is labels, which are categorical. So write down the 2 categorical ones. And then, so when I say which question data sets are you going to use, write down the 2 categorical ones. You know, like favorite type of food and city you live in, whatever they are. And then answer a couple questions. Answer a question about Pareto charts and answer a question about pie charts. And those are from our notes and things we did in class. So that's it. It's due next Tuesday. All it is you committing to some questions, picking some questions and committing to them. So that's not difficult. What you should have done already is part 1B, which is getting all 30 of your questions from your 4 people, cleaning them up, and then merging all 30 of your questions into the master file. But we need all 30 of them, because people are going to be picking different questions, and they need all of the data from everybody, for all of them, right? Okay, so make sure we're clear on that one. So you need to clean up all 30 and transfer all 30 over. And then from there, after you do that, then you're going to choose 4 that you're going to work with personally. Okay, great. Here's information about exam 1. You need to bring a pencil. Look at the study guide at the back of the room for the topics that are covered. The solutions to the study guide are all on Canvas under study guides. I would recommend that you ideally do all your problems first, and then when you have questions, then you can go, after you finish everything, then go back and see what the study guide, check your study guide to answer your questions, and also to see what you might have missed that you think you got right and you didn't. So check those also just in case. Okay, so to the exam you need to bring a pencil, a half-page one-sided of notes, which I talked about earlier, that have to be handwritten by you. Scratch paper if you want it. People rarely use that, but you can bring it. And then at least a basic calculator. You can use any calculator you want except for your cell phone, obviously. No personal communication devices. So just a regular calculator, all good. And your binder in order for extra credit. Okay. You get extra credit for your binder, up to 2 points for that. If you attend 2 Smart Shops, bring those little Smart Shop attendance slips, and I'll take them, I'll tear them up, and I'll give you a little +1 on your exam for that. 1 point for the two Smart Shops. If you have gone to 4 hours of tutoring, so that's either in the tutorial center or my friend Jim is doing it over here. He ends at 5:30, which might be a little bit early for you guys. But some of you guys are around. I see some of you guys on campus at random times of the day, so you guys are here. If you have 4 hours of tutoring, then you can, on campus, then there's different ways of getting proof of that, like printouts and things like that. Or if you're in the support course. So there is that support course. There's like 4, raise your hand if you're in the support course. You are, okay, yeah, so there's a bunch of you that are in it. Write down support course on your exam, and then I'll check and make sure you've been going, and then I'll give you 2 points on your exam for that. But make sure you write it down so I know to check. Great. And I would also say, if you're in one that's right before this class, that's easy. But if you're one that's like some other random time, maybe tell me what time it is, because there's like, well, there's 10 of them. I can look through 10 of them. It's not a big deal. Forget that. All right. My friend Jim, he's the guy, that stat guy I was telling you about from Lawrence-Livermore Lab that retired. He did statistics there for decades. He's the one who convinced me, don't do it like this. People don't do it like that in real life. He is willing to, I negotiated with him to work with you guys Tuesdays from 4 to 5:30. So if you have any questions about stuff, you can ask him. He's there in the tutorial center, in the Math Learning Center, 600, from 4 to 5:30, and he can answer any questions you guys have. Also, you guys know that Tuesday nights, I'm here for like half an hour after class just to answer questions for you guys. So if you have questions about your homework, just stick around Tuesday nights afterwards and we can talk about whatever. Because I know night class, a lot of you guys work until you come here, so after class is better. So those are all things. If you are going to do this, there's a computer you sign in on. I think you have to sign up for 202C in order to do that first, so talk to me about how to sign up for that and I can help you, or you can talk to them about how to sign up for that also, and they can help you out with that. All right. Good. Addition rules for probability. How about 1? Go ahead and read for us. Simultaneously. Right, so if they cannot occur, if they cannot occur at the same time, like you can't roll a 4 and a 3 at the same time. It's either going to be a 4 or a 3. You guys see what I'm saying? A puppy cannot be a black lab and a chocolate lab at the same time. Those are mutually exclusive. You can't be both. Cannot be both. Okay, keep going, Juan. So here's the first rule.
Okay, they refer to the same string, symbol, dice.
Oh, no, this part here. So capital P, we call that probability. And then the parentheses, we pronounce that of. Okay, so of, whatever's inside. So go ahead. The capital P, we call that probability. It's called probability. Whenever you see probability, that means capital P, that means probability. And then parentheses means of. So this is probability of
Probability of A or B equals probability of A plus probability of B.
Good. If it's mutually exclusive. Great. So you guys have to get used to seeing these as they come out. Probability of A or B. So I'm kind of making different people read them. Angelo, go ahead and read the next one.
Probability A or B.
Of A.
Probability of A or B equals probability of A plus the probability of B minus the probability of A and B, not mutually exclusive.
Good. Makes sense? And you guys know this one. Right? If they're mutually exclusive, you just add their probabilities. Right? Probability, you pick a red marble or a blue marble. You just add their probabilities. If they are not mutually exclusive, in other words, they have some overlap, like the yellow labs and the male labs, you add the yellow lab, you add the probability of the male lab, and you subtract the overlap, right? Because it's being double counted. It's getting counted in this group and in that group. So you guys know this. Just review. Multiplication rules. Kat, go ahead and read the first one.
Probability of A and B equals probability of A times probability of B.
Yeah. So the independent, you just multiply the probabilities. And you multiply. The next one, how about Rosa? Oh.
The probability of A and B is equal to the probability of A times the probability of B
if it's dependent. So this one is saying, if they're dependent, then first you find the probability of the first one, probability of A, and it's like you draw a tree, branch towards A. Now you're at A. Now you multiply that by the probability of B given A has happened, because you've already taken that step towards A. So from A, the probability of B given A has happened. So that's if it's dependent. So what happens when I roll a die? What's the probability I roll a 4? 1/6. What's the probability that now I flip a coin, it's heads. Now what's the probability I roll a 4? 1/6. These are independent because the probability doesn't change just because I've rolled the heads or I rolled the tails. Please note this. I'm looking at probability of 4 and probability of 4 there also. So both times I'm comparing the probability of 4. This is probability of 4 given nothing. This is probability of 4 given I flipped whatever, given this has happened. Does that make sense? But both times it's the probability of 4 that you're comparing. If it hasn't changed, then that means that the coin flip didn't affect it. They're independent. All right, so this is your quiz problem. Are yellow and male mutually exclusive? Are they or not? Not. Why are yellow and male not mutually exclusive? Because they can happen at the same time. Right? You can be both. You can be both. Good? All right. Are male and yellow independent? I'm getting some no's, some yeses. So find someone next to you. Talk to your neighbors about this. Are they independent or not? Talk to your neighbors. What do you guys think?
Yes, they're dependent.
No, they're not independent. Why or why not? So, yeah, go ahead.
I was just going to say they're dependent because there's overlap and you can be male and yellow.
That's about mutually exclusive. That's mutually exclusive, which is, people get those confused all the time. Overlap is all about mutually exclusive. What were you saying?
So the probability that they're yellow, absolutely, is 4 out of 20.
Right.
The probability they're yellow given they're male is 4 out of 12.
Oh, actually you're thinking, well, probably their yellow is 6 out of 20. And yellow given, so yeah, so you're getting some of the right things. So let's take a look. Yellow and male, what are the numbers that matter to that?
4, 12.
Okay, so 4, which is the yellow and male. Does that make sense? Okay, what else do we need? The total yellows, great. What else? The total males. Everybody on board with that? And the total. It should make a square or a rectangle. So we're going to look at 4 over 6 and 12 over 20. Maybe I shouldn't do those. So we're going to look at 4 over 6. Is it? And 12 over 20. They are not equal. Does everyone see that? That's all you need to do. Is say 4 over 6 is not equal to 12 over 20. Done. So looking at those ratios. The ratio of the males, 12 out of 20, the ratio of male given yellow. So this is the probability of male. This is probably male given yellow. They're not the same. You have to actually double check and make sure they're not the same. Because sometimes fractions look like they're not the same when they really are. Right? So you have to check that and say, oh, 4 divided by 6 in my calculator. Oh, it's 66666. Great. 12 over 20. Oh, that's 0.6. They're not the same. Right, 0.66666 and 0.6 are not the same. So then you'd say, oh, they're different, they're not equal, they're dependent. That's one way of doing it. The other way, which is also a good way, is to do this. What's our rule for, what's the multiplication rule if they're independent? If they're independent, we know that what? Probability of A and B. So in this case, it would be probability of male and yellow is equal to what? We just did it. We just did it like 2 slides ago. What was it?
Probability of A times the probability of B.
Yep, probability of A times probability of B. So in this case, probability of male times probability of yellow. So the question would be, does this equal that? Does it equal it? Let's see. What's probability? Okay, so let's go up here. Everybody find the probability that they're male and yellow. It's a male and yellow puppy. With your neighbors, 5 seconds, go. If you're not talking to your neighbor, I'm probably going to call on you. Derek, what's the probability that they are a male and yellow puppy? I'm sorry? How many are male and yellow? 4. So you see that? Out of how many? 20. So what's the probability? I'm sorry? 4 out of 20. Great. Good. Now, the question is, does this equal, what's the probability of male? Everybody find the probability that you're male. 12 out of 20, everybody on board with that? And what's the probability that they are yellow? 6 out of 20? Yes? Exams in like a week from Tuesday. You guys good. Stay with me here. Okay, 6 out of 20? So if I multiply these, I will get 0.2, and this will be 0.18. Are those equal? No. So it's dependent. Because if it was independent, they would be equal. Do you see what I'm saying?
We've had 6 over total.
Oh, sorry. Thank you. So that would be the same then. Sorry, I was leaving something else. Right. So if probability of male times probability of yellow does not equal probability of male and yellow, then they can't be independent. Because the law of multiplication says that if they were independent, they would be, those two things would be equal. Everyone follow that? So if they're not equal, then they can't be independent.
So you use the independent to check the independent?
Yeah.
Okay.
You check the independent to check to see if it's independent.
Yeah. Okay.
So the multiplication, you can use the multiplication rule for independence of independent items to see if it really is independent. And if it doesn't follow that law, that rule, notice if these are not equal, then it can't be independent. So that's another way. You can use either one of those. If you like the ratio thing, just do the ratio thing. The proportions above where you circle, 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 and put one over the other one. Right? So you can say you have does 4 6 equal 12 20ths? Okay. Quiz problem number 2. So remember, with sets, this means union, right? It means or. I take you and I take you. I take everybody. Or. So here, we're saying they're mutually exclusive. What's up with the mutual? If they're mutually exclusive, that means what?
Add probability of A plus probability of B.
Yeah, you can just add them. Right, which means that for probability of A or B, you just add them. Because this, there is no overlap. This is 0. So does that make sense? So, no overlap. So you can just add them. And you'll get 0.86. Good? Yeah.
On the test, do you want us to write it just like put the answer at 0.86 and then box it, or is there any specific way?
I would like you to do 0.32 plus 0.54 equals.
Okay.
Yeah. So in general, on your exams, I always want you to show your work, right? Because two things. One, you might get partial credit, and two, I need to know how you got that, what your thought process was. It wasn't like I just guessed right, or I copied from Johnny down the street. I don't know, whatever, right? I need to know what you're thinking of, what your thought process was as you got that answer. Because you can get the right answer the wrong way, and that doesn't work. You know what I'm saying? Quiz number 3. So remember that kind of upside down guy? It's like that bow-legged cowboy. One leg is in A, one leg is in B. He's in both. That's and. He's in A and he's in B. So here, we want to know what the probability of A and B is. So first off, how do we know for sure this is definitely not mutually exclusive? Because how do you know there's intersection?
Doesn't say. Because it's and.
Well, because we told you there is, because we're asking you to solve for it.
Does it say because P and B, I mean, B and A?
What was that?
Does it show A and B? Is it because it says P of
Well, we had that last time. We had P of A and P of B.
A? I also see the,
What was that? I have and. Okay, yeah.
P of A plus P of B is greater than P of A or B.
3 classes. You're the first person to come up with that. That's awesome. So she's saying P of A plus P of B is more than P of A or B. It doesn't. If they were mutually exclusive, if you add them, they should just equal P of A or B, right? Apparently that's kind of a lot to ask because like everybody was like, what? So yeah, so that's it. If you add them, if they're mutually exclusive, when you add them, it'll equal probability of A or B. But instead, it's larger than probability of A or B. Do you guys see how probability of A or B is 70? So when I take everybody, I only get 70% of the population. But each group, if you add them up separately, I get more. It's more than 70%. So there must be some that are in both groups.
so why are there different, forgive me, the legs?
The and?
And, yes.
Right. So the and, that means that they're in both. So there is some overlap.
And then, but they have upside down and,
So this is upside down and. This is union.
okay.
This is the or. This is everybody.
That shows that it is every,
This is so if A plus B equals this, then they're mutually exclusive. There's no overlap. If A plus B is more than this, that means that there must be some things that are getting counted that in both groups.
which it says in the problem. And P,
Yeah, but you know for sure because when you add the two groups together. So in other words, I have a bunch of Skittles. Right? I have 5 red ones. I have 3 green ones. If I look at the red or the green, I should have. What's probably I get a red? Okay, so 50% are red, 30% are green. What's probably I get a red or green one? 50% plus 30%. If the probability I get a red or green one is only 60%, some of them must be half red and half green. Does that make sense? There must be there's something wrong with that. It's not that important. I don't want to spend time on it, but that's kind of cool. But when you guys sorted that out. So here's the deal. We know that this is 0.32. We know that this is 0.54, and we know that them together is 0.70. So that's the Venn diagram of it. So what we're going to do is we're going to look at that probability of A or B is equal to the probability of A. I should do this in colors. Is equal to the probability of A plus the probability of B minus the probability of A and B. I should make you guys do this. Let's do this again. So, I'm looking at puppies. What's the probability that it's yellow or male? What do I do? I want to find the probability that it's a yellow puppy or a male puppy. What do I add? What do I do? Somebody give me something. Probability, yeah, you take the probability that's male and the probability it's yellow, right? You take the two probabilities. So probability of the first one plus the probability of the second one. And then we do what? Subtract the intersection. Subtract the overlap. Make sense? Good. Now, we have some of these. The red one, A or B, A, B. If I have 4 unknowns, right? I have 1, 2, 3, 4 things here. If I know 3 of them, can I find the 4th? Yes. So if you haven't done it, do it now.
Yeah. Yeah. It's okay.
Okay, so let's see what we got. Let's probably have A or B, 70%. Is that right? And that should equal probability of A, which was 32%.
32,
And then
54.
54. And then here's where the algebra comes in. So we're going to draw our little line down the middle, kind of keep them separate.
6 plus 9.
So we're going to combine like terms first, right? Combine these two. Maybe I'll use that in a different color. Combine these two. And we end up getting 0.70 equals 0.86 minus probability of A and B. And then we can add probability of A and B to both sides. And we'll get 0.70 plus probability of A and B is equal to 0.86. And then we can subtract 0.70 from both sides. And you end up with probability of A and B is equal to 0.16. Alternatively, you could just, at this spot up here, you could say, well, I have 86 cents. I lose some, and then it was 70 cents. So how much do I lose from 86 to get to 70? 16 cents, right? So you could just logic it out that way also. All right. Good? Questions? Do you need to consult with your neighbors? Yes, no?
No, ma'am.
Nope. All right, keep going. All good. Here is the quiz problem 4. Wow, we need to move quicker. All right, so you have 2 red marbles, 3 blue marbles in a bag. You draw it, replace it, draw again. Here is the long way. You do 1 branch for each marble, right? So 2 reds, red, red, 3 blues, blue, blue, blue. And then from the red, you replace it, so the second part's the same. For the second draw, red, red, blue, 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 red, red, blue, blue, blue. And then these ones I ran out of room, so I had to put them on the next slide. Here are those. The blue ones, yeah? You could do it that way. Which is totally fine. However, from here on out, we need you guys to do it a little more efficiently because we're going to get to things with 10 marbles. Yeah, and so you're going to have 10, and then each 10 is going to have another 10 off of that. That's crazy, right? So instead, take the reds, make them into 1. Take the 3 blues, make them into 1. They will no longer, these are equally likely. Everybody follow that? These are all equally likely. They will no longer be equally likely, but there'll be other easier ways of finding those probabilities. So let me show you what I mean. So instead, we'll do this. So I could, when I draw a marble, it could be red or it could be blue. How many are red? 2 out of 5. So the probability I draw a red one is 2 out of 5. What's the probability I draw a blue one? 3 out of 5. I've just taken those 5 branches and changed them into probabilities instead. Instead of them being equally probable, then they are different probabilities. Again, the second draw would be 2/5 red, 3/5 blue, 2/5 red, 3/5 blue. So now they're not equally likely anymore. Everybody on board? Mm-hmm. So in other words, the probability of getting blue then red is not 1/4, 1 out of 4, because they're not equally likely. Everybody got that?
It's like the river thing, right?
It's the river thing. Exactly. It's exactly the river thing. Speaking of the river thing, that's okay. So what's probability we have red then blue? It was this way, right? Was it red then blue? We're going to multiply the probabilities. So 2/5 times 3/5. In other words, 3/5 of 2/5 of the river. And we multiply probabilities, we multiply fractions. Multiply the numerators. So 2 times 3 is 6. And you multiply the denominators. 5 times 5 is 25. So 6 out of 25.
0.24.
Right. So generally speaking, if you're given, I'll talk about that later when we get there. 1 second. Let's take a look at these guys. So here, red then blue. How many of them are there? This one, that one. Bump, bump, bump. This one, right? Mm-hmm. And then over here, no, these are all blue first, so none of those are red then blue. So we have 6 out of 5, 10, 15, 20, 25. So 6 out of 25, which is exactly what we got in the other way. It's just a little more, it's just more writing. Good? Okay. And again, that goes back to this river. My river, I love my river. So think of this river again. The whole thing is a river that's flowing, right? It branches. 1/3 goes to red, 2/3 to blue. You're in the third that went to red. It branches again. 1/3 goes to a second red, 2/3 to a blue. This third that goes to red, though, is not 1/3 of the whole. It's 1/3 of 1/3 of the whole, because it's branched once already. So it's not the whole river. 1/3 of 1/3. Right? We see it split, so now it's less of the river, and then it's even less 1/3 of that, so it's 1/3 of 1/3 That's just 1/9 of the whole thing. Here, how do you get here? Well, this is 1/3 of 2/3, so 2/9. This one here is 2/3 of 2/3, 4/9. They're not equal, right? Because they're not equally likely. Good? All right. Now, let's look at stress. This is a slight variation. A Harris poll. Why am I reading? Adam, read.
Yes, ma'am. A Harris poll found that 46% of Americans say they suffer great stress at least once a week. If 3 people are selected at random, find the probability that all 3 will say that they suffer great stress at least once a week.
Great. Here is a person, a random American. What's the probability he suffers great stress at least once a week? Guys, what's the probability he suffers great stress at least once a week?
46%.
What's the probability she does? 46%. What's the probability she does? 46%. Good over there? Okay. So what's the probability that she does, and she does, and he does? And we multiply. So 0.46 times